aircraft has a magneto spark ignition system. If you turn the ignition switch to off and the engine continues to run, this is abnormal and should not happen. Leaving carburetor heat on during takeoff is going to increase the ground roll. Fouling of spark plugs is more apt to occur if the aircraft is climbing into less dense air without the adjustment of the mixture setting. So fouling of spark plugs climbing into less dense air without the adjustment of the mixture setting. The most probable reason an engine continues to run after the ignition switch has been turned off is a broken magneto ground wire. So a broken magneto ground wire is why the engine would continue to run after the ignition switch has been turned off. If the ground wire between the magneto and the ignition switch becomes disconnected in a spark ignition system, the engine can be started accidentally. So again, with the ground wire between the magneto and the ignition switch becoming disconnected, the aircraft can be started accidentally. A pilot controls the air-fuel ratio with the mixture control. In order to maintain the relationship between manifold pressure and propeller RPM, it is necessary to reduce the manifold pressure before reducing propeller RPM. So reduce manifold pressure before propeller RPM. Detonation can be caused by using a lower grade fuel than recommended. Detonation, lower grade fuel than recommended. The uncontrolled firing of the fuel-air charge in advance of a normal spark ignition is known as pre-ignition. In a normally aspirated engine, proper adjustment of the mixture control is required to decrease fuel flow, which compensates for decreased air density at higher altitudes. Decrease fuel flow for higher altitudes. Decreased fuel flow, which compensates for decreased air density at higher altitudes. Which statement is true concerning the effects of the application of carburetor heat? It enriches the fuel-air mixture. Propeller efficiency is the ratio of thrust horsepower to brake horsepower. Propeller efficiency, thrust horsepower to brake horsepower. An fixed pitch propeller is designed for best efficiency only at given combination of airspeed and RPM. The main reason for the variations in geometric pitch, so the twisting force along a propeller blade, is to permit a relatively constant angle of attack along its length. The best power mixture is that fuel-air ratio, which the most power can be obtained for any given throttle setting. Applying carburetor heat will enrich the fuel-air mixture. High oil temperature that exceeds normal operating limits could indicate low oil quantity. What will occur if no leaning is made with the mixture control as the flight altitude increases? The density of the air entering the carburetor decreases and the amount of fuel remains constant. Unless adjusted, the fuel-air mixture becomes richer with an increase in altitude because the amount of fuel remains constant, but the density of the air decreases. If the pilot does not adjust the mixture control of a normally aspirated engine while climbing to higher altitude, there will be a excessive fuel flow compared to the decreased air density. At high altitudes, an excessively rich mixture will cause the fouling of spark plugs. Excessively rich mixture will cause the fouling of spark plugs. In an aircraft with a constant speed prop, a decrease in the manifold pressure will cause the governor to decrease the propeller pitch to maintain engine and propeller RPM. So a decrease in manifold pressure will cause the governor to decrease the propeller pitch in order to maintain engine and propeller RPM. If a pilot notices a cylinder head temperature rising above normal limits, what are some of the methods to lower temperature to normal operating limits? Increase your airspeed, enrich the fuel-air mixture, and/or reduce engine speed. Continuously exceeding the manufacturer's limitation on maximum manifold pressure may result in damage to the cylinder components and possible engine failure. In a reciprocating engine, extremely high temperature will result in detonation. Spark plug fouling in normally aspirated aircraft engine may be the result of excessive carbon buildup. Spark plug fouling, excessive carbon buildup. Detonation is likely to occur when the mixture is really lean. Detonation is likely to occur when the mixture is really lean. Pre-ignition in a reciprocating engine causes the engine to lose power. Pre-ignition causes the engine to lose power. What will occur if no enrichment is made with the mixture control as the flight altitude decreases? The density of the air entering the carburetor increases and the amount of fuel remains constant. So the density of the air entering the carburetor increases and the amount of fuel remains constant. In an aircraft with a reciprocating engine, if you were to leave the carburetor heat in the on position for takeoff, the engine would create less power. When cruising en route to your destination, you notice your oil temperature is reading high and oil pressure is low. What could be the problem? The oil is below minimum oil needed. What happens when the pilot operates the manifold pressure lever on an aircraft equipped with a constant speed prop? When the pilot increases the throttle, the governor increases propeller pitch to maintain constant RPM. What happens when the pilot operates the manifold pressure lever on an aircraft equipped with a constant speed prop? When the pilot increases throttle, the governor increases propeller pitch to maintain constant RPM. A pilot turns on the carburetor heat in the aircraft. The pilot expects less performance in the engine because the mixture has been enriched. Why does a reciprocating engine lose power when carburetor heat is turned on? The fuel-air ratio is enriched. An excessively rich mixture will cause the engine to run rough. This is due to excessive fuel not being burned completely and fouling the spark plugs. To maintain reason for the variation in geometric pitch, the twisting force, along the propeller blade is to produce uniform lift along the length of the propeller blade. When climb airspeed will give the best engine cooling, more control authority, and better visibility over the nose of the aircraft. In cruise climb. Cruise climb gives best engine cooling, more control authority, and better visibility over the nose of the aircraft. When you start an engine, the oil pressure has not reached the lower acceptable limit in 30 seconds. What should you do to prevent engine damage? Shut down the engine immediately. Flight conditions where air is unable to enter the fuel tank through the vent as fuel is drawn to the engine will cause fuel starvation. Fuel is unable to enter the fuel tank through the vent means fuel starvation. An airplane equipped with a dual ignition system, what is the normal indication when selecting either the left or the right magneto during pre-takeoff check? Just a small decrease in RPMs. Why is practicing emergency descents not recommended? The engine cylinders could be excessively cooled. To maintain power in a normally aspirated engine when transitioning to a lower density altitude, decrease the throttle setting. To maintain power in a normally aspirated engine when transitioning to a lower density altitude, decrease the throttle setting.